In this video, we're continuing section 3.4 on combining functions, and we're going to do some examples where we look at some compositions of functions and we find their domain and sketch them. All right, so we have this function f of x, which equals square root of negative x, and g of x equals x squared. And in part A, it says, let's look at f of g of x. And I want to evaluate each expression, find the domain, and then sketch the curve. Alrighty, so f of g of x. So this means I'm looking at f, and then within it, I'm going to be plugging the function g of x. So g of x, the formula for it is x squared. So what that means is this whole thing that's inside the parentheses, this whole x squared, it's going to get plugged into the function f of x, where the variable x is. We're going to replace that x with this x squared. All right, so if we do that, we get square root. And instead of just square root of negative x, that x gets replaced by this x squared. In fact, maybe I'll put it into parentheses. So x squared. X squared is getting plugged in where that x is. Okay, but I don't really need that parentheses. So if I write it without the parentheses, we get just the square root of negative x squared. And that's actually as far as I can simplify this. I can't cancel the square root with the squared because that negative sign is in the way, so I can't cancel them. So this is as far as I can simplify it. So it wanted me to find the domain. And to find the domain, I need to think about the restrictions of the function. So the restrictions. Okay, so with this function, I see one restriction. If we have a square root, the stuff that's inside of the square root, which is negative x squared, the stuff inside their square root, has to be greater than or equal to 0. And now I have to solve this inequality. And with this one, I can simplify it a little bit by dividing both sides by negative 1. That'll give me x squared on the left, and then 0 on the right if I divide both sides by negative 1. And dividing both sides by negative makes me flip the inequality. So I get x squared is less than or equal to 0. And with this inequality, we can kind of just use logic and think about what would work in our head, because there's only one value that works with this. So let's think about what that would be. Take a quick pause for 15 seconds. See if you can figure out what x value we can plug in that makes this inequality work. Only one value will work. All right, so hopefully you did that. Hopefully you paused it and thought about that for about 15 seconds. It turns out the only value that works is x equals 0. So only x equals 0 works, which means my domain, I'll write D for domain, well, it just has one number in it, 0. So in interval notation, the way I write that is I put 0 and then I put it within curly brackets if there's just one value in the interval. Okay, so that's my domain. That's part of what the problem wanted. And now I'm going to sketch the curve. So sketching the curve, so our function y equals square root of negative x squared. Let's draw some axes. So y-axis, x-axis, and because the domain only has one value in it, 0, that means the graph is only going to have one point on it. And that the x value of the point is 0. And if I were to plug 0 into this equation right here, well, y is going to equal 0 as well. So the only point on the graph is when x is 0, y is 0. So that's the origin. It's a little weird, but this graph only has one point on it, and that can happen. Okay, all right, so let's look at part B. In part B, I want to take the composition in the other direction. So what if I'm plugging f of x into g of x? So here we have g of, and then I'm going to write f of x. So the formula for f of x is square root of negative x. Okay, so the whole thing that's inside of the parentheses is this square root of negative x. That needs to get plugged into the formula for g of x where the x is. So instead of x squared, I'm going to be plugging in that square root of negative x in. Okay, so let's do that. So we will get, instead of x being squared, I'm going to plug in for x this whole square root of negative x. That whole thing is going to get squared. Okay, and this time I can simplify it a little bit. So if I have the square root inside and the squared outside, I can cancel them and I get negative x. Okay, I'm not going to box that just yet because I'm going to find the domain. It turns out there's an important condition I'm going to have to include with that. All right, so let's think about domain and let's think about restrictions. So domain, let's think about restrictions. All right, so let me scroll it down a little bit. Okay, so one very important takeaway is that when you're simplifying a function and you're finding the domain, we must identify the domain before we remove any restrictions. Like before I do a step where I get rid of a square root, or before I get rid of a denominator. Before I removed those restrictions, I need to find the domain at that step. So like if I look at the very last step, where I have, let me go to draw mode, where I have this negative x. Well, the restriction that used to be there in the previous step, which had the square root in it, well, that square root has disappeared. So I have to be looking at the step where the square root is still there in the problem when we identify the restrictions. Okay, so let's look at that step. And, well, there's one restriction. There's a square root. So what's inside of it, negative x, has got to be greater than or equal to 0. So just like with the last problem, I can first divide both sides by negative 1. And that'll give me x. Flip the inequality, less than or equal to 0. And now, well, I got this inequality solved. I have x is less than or equal to 0. So that means when we set it simplified to negative x, I'm going to put a comma after it. And now I'm going to include this restriction that x is less than or equal to 0. So that is representing my domain. Okay, so my domain here, if I write this in interval notation, would go from negative infinity to 0 with a bracket because it could be equal to 0. Okay, so that's my domain. All right, so what does the graph of this look like? So I'm gonna actually sketch two sets of axes. So axis 1 and axis 2. Because in the first axis, I want to look at the graph of y equals negative x without that restriction. And in the next one, we'll look at y equals negative x with the restriction that x is less than or equal to 0. All right, so what does the graph of y equals negative x look like? Well, that's a line. It's got a slope of negative 1, and it's going through the origin. The y-intercept is 0. Because that's our graph of y equals negative x. So, well, with this condition, that x is less than or equal to 0, this restriction, that's limiting my domain. Now I'm only looking at the values where x is less than or equal to 0. So that is only going to be the part of that line where x is less than or equal to 0. It's only this left half of the line. Okay, so that is my graph. So having the domain, identifying the domain is very important in being able to sketch the graph and knowing, well, is it the whole thing or is it just part of it because my domain is limited?